Hi folks, in this video we're going to continue on from what we did in completing the square. For completing the square, we learnt how to take a quadratic in the general form here and convert it into the vertex or turning point form. And the reason why we do this is because it is much easier to graph. If we have something in this format here, the general form, and we have a number in here, it isn't always obvious what our shift is going to be. However, once we put it into the vertex or turning point form, our shift is now H here for horizontal and K for the vertical shift. So our first step is to get familiar with recognizing when something is already in this form. So we are looking for y equals a x minus h all squared plus k. And we can see, for example, that a is not in this form. We look at b, and we can see that it is in fact in the simplified version of this form. Our h is 0. So we would say yes. Now this is like we've got x squared minus 3 here. We can see that c is in the right format. D, yes. It doesn't have a k, so there's no vertical shift. But we can see that E is not. And F is also not, because we have a cube here. But G is, and H is. What we're going to do now is we're going to work through the various transformations of our parabola. So they're summarized in this slide and this slide here, but we're going to work through it as well. Let's start with the simplest parabola we can have, y equals x squared. We see that the turning point is at the origin, 0, 0. It's facing upwards. What we're first of all looking at is what happens if we're changing A, which is called our dilation factor. If we make it a negative, we are going to flip the whole graph upside down here. See how it is flipped across the x-axis. If we change A, the dilation factor, if we make it a larger number than 1, we're going to make our graph steeper, like this. So this would be y equals 2x squared. If y is a fraction, it's going to be shallower, more open, like this. So this would be y equals 1/2 x squared. Next, we're going to put in a vertical shift. So this is the k on our graph. If we add 3, so x squared plus 3, every value is now going to be increased by 3. So our whole graph here is going to move upwards. Our turning point is going to be at 0, 3, and our graph will be the same shape as before, but it's now being raised, lifted 3 places. If we have a negative 2 here, we're going to move the whole graph down 2 places. So now our turning point is going to be at 0, -2. So our graph will be the same shape, but move down 2 spots. The horizontal shift, we look at h, this number in here. One of the tricks is that the sign here needs to be taken into consideration. If this is negative, the whole graph is going to shift this way to the right. If we have a positive, the whole graph shifts to the left. An easy way to remember that is just to think the vertex, the turning point, is at H and K. So for example, here we have y equals x minus 2 all squared. That means that h is equal to 2, the whole graph shifts to the right 2 units. If we've got y equals x plus 3 all squared, we notice that this is a plus, not a minus. So we're going to move the whole graph to the left. And next, we're just going to practice looking at the equation and working out what the turning point is. So for the first one, A, it's going to be 5, 0. The graph is going to shift to the right, but no up or down, no vertical. B, we notice, oh, this is positive. So we're going to have -7 and 3. C, it's going to be 2 and -7. D, 1 and 8. So all we have to do is look at our equation and go, whatever h is, that is the x coordinate, k is the y coordinate of the turning point. So it's also telling us how much we are shifting, either horizontally or vertically. So when we are given an equation in the vertex form, we work through a number of steps to graph it. We go, which way up is it? Is A positive or negative? Is there a dilation factor for A? Where is the turning point or vertex? It can be helpful to start by drawing the basic graph y equals x squared and then applying those transformations. So for example, here our turning point is now going to be at 4 and 2. So we take this graph here, we move it across 4 and 2 up. This is our new turning point, and we would just draw the whole graph over there. Here we go. Our turning point is going to be 1, -1. There's no dilation factor, again, so we don't need to worry about that. So we go, x is 1, y is -1. So now our turning point is down here. So our graph will be down here. Sorry, that's a bit wonky, that one. Here, we now have a dilation factor. We've got a 2 here, which means that it is going to be a steeper graph. And our turning point is going to be at -5 and -9. So we will have a steeper graph. So I'll just sketch that shape roughly in here. We would then go -5, -9. So off our graph paper grid here and sketch it in here. Here, our dilation factor is -1. So it tells us that we are going to flip the graph upside down, and our turning point is going to be at 8 and -9. So it would be 8 for our x-axis, -9 for our y, and we will have it upside down. So this shape here. Here, we're going to have a dilation factor of 1/3, which tells us it's going to be more open, shallow, like this. And our turning point is going to be at 4, 4. So we would start with y equals x squared. We would then sketch out what y equals 1/3 x squared would be. So instead of passing through 1 here, it will pass through 1/3. It's going to be quite open and shallow. And then we are going to move it across 4 to the right and 4 up. So our new turning point is going to be here. These questions, we're working backwards from that. We're being told that our dilation factors are all 1, and we have to work out what the equation is. So we look at A. We can see it's right way up. So it's going to be y equals x minus 2 all squared plus 4, because they've given us the coordinates of the turning point, and we are going to insert those into the equation. For B, we can see that it's inverted. So it's going to be y equals negative x. We're told that it's at -1, so it'll be +1 all squared plus 5, because the coordinates of the vertex or turning point are -1 and 5. And we can see that these questions, we would do exactly the same way. We would go, this is a negative because it's inverted. Here are our turning point coordinates. So we would put those into the equation. Okay, that's it for this